In this video, I wanted to answer this question. Relates to the put-call parity condition. The first thing to say about the put-call parity condition is that there's two strategies that should give us exactly the same payoff in any contingent state of the world. And those two strategies, the first strategy is to buy a call option with a strike price of X and invest enough money to get the strike price next period, next year. So here I'm assuming it's a year. We could multiply by T if we're not doing a year, right? But that's the PV of my strike price. And the cost of that strategy should be equal to the cost of buying a put and buying the underlying, which is our second strategy. These two strategies give us exactly the same contingent cash flows at maturity of the option. So for this reason, they should be priced at the same price today. They should be equal. And this question is trying to showcase and discuss these concepts. Okay, so first question is simply just, does this information here respect the put-call parity condition? Okay, well, let's just fill in the numbers in here to see if it respects it. C is the price of the call option or the call premium. X is the strike price on our option. And then this is actually the PV of the strike price. And because in this case, just replace this with the 3%. In this case, the discount rate R is 3%. And I multiply by T because this option doesn't have a maturity of 1 year, it has a maturity of 3 months. So we use the simple interest rate formula to calculate the present value of that strike price. And we know that this should be equal to the put premium plus the value of the underlying, which is currently priced at $98.63. Okay, and now we can just calculate all of the size. Obviously, in an exam, I'm more likely to just leave one of these variables unknown and you need to solve for it. So just make sure you're able to do some basic algebra. But in this case, I just ask, okay, is the condition respected? Well, let's just verify. So let's start by the bottom here, 0.03 times 3 divided by 12 plus 1. So that's the 1 plus 0.3 times 3 divided by 12. I want 100 divided by this. So this number here is 99.2555813. I add 0.05 to this number. And we get a left-hand side that is 99. That is 99.30558313. And this should be equal to whatever we have on the right hand side here. So let's just do it. Those are just two numbers, one plus the other. And on the right hand side we have 99.33. Okay, so in this case, the put-call parity condition is not respected. The right-hand side strategy, buy the put and the underlying, costs more than the left-hand side strategy, buy the call and invest enough money in the risk-free asset to get the strike price at maturity. So the condition is not respected. In the previous video, I tried to showcase that no matter which strategy you use, okay, you will get exactly the same value in the future. If those two strategies don't cost the same amount of money. What you should do is you should short the expensive strategy and you should go long the cheap strategy. Now, I won't repeat the argument here, but in the previous video, you should have been convinced that if I use this strategy or this strategy, I'll get exactly the same cash flow in the future. So if I'm short one of the strategy, I'll need to pay that amount of money to someone. If I'm long the other strategy, I'm going to receive that amount of value. So basically, in the future, I will get a cash flow of exactly zero. I'll get a cash flow of nothing in the future because one strategy will exactly cover, right? The benefit I get from one strategy will exactly cover the liability that I get from the other one. So I get zero cash flows in the future. I don't ever need to pay anything. But today, I went short the expensive strategy. So if I go short the expensive strategy, I make that money right away, right? I sell that to someone. So I get $99.33 today. But I went long the cheap strategy, so I needed to pay to buy the cheap strategy. And I needed to pay $99.31. So I made 2 cents today. I make 2 cents today every time I go long one strategy and short the other strategy. But remember, in the future, the cash flow from the long strategy will exactly cover the cash flow that I owe from the short strategy. So in the future, my cash flow will be $0. So I make 2 cents today every time I go long the cheap strategy and short the expensive one, and then I owe people $0 in the future. Suppose that I do that 10 million times. If I do that 10 million times, I'll make what, $200,000? I'll make $200,000. So as long as there is a disequilibrium between the price of these two things, I'm losing nothing in the future to make free money today. So go ahead, right? And this is why the put-call parity condition is important, because these two things have to be equal. And again, you need to understand the previous video for it to make total sense. Once you understand the previous video, you understand that in the future, I'm actually losing nothing. This strategy and this strategy will completely cancel each other out, right? If I'm short one of the strategy, I'll need to pay the payout to someone else. But if I'm long the other one, I'll receive the payout. And since the two payouts are exactly the same, nothing happens to me in the future. Okay, that's it. That's the video on the put-call parity condition. Or the last video, at least.